Okay, I'm going to take some time, go over the study guide. It's mainly for the people that weren't here, but if you weren't, congrats, you get the benefit of me going over it. There'll be 5 questions. You're going to find the scale factor with the new length and the old length. You're going to use that scale factor to apply to a length. So you're going to multiply, or you're going to do something with the length. Then you're going to do the same thing using the same scale factor for area, and then the same scale factor to solve a volume problem. At the very end, you're going to find some dilations on the coordinate plane, and that'll be it. Some definitions or formulas that you need, so I wanted you to write down the definitions and the formulas if there are any that apply. Dilation, it's a stretch by a scale factor in every direction. Every direction. Jumping a little bit ahead. Area has 2 directions that you need to go. Volume has 3 directions that you need to apply the dilation to, and length is only 1. Scale factor. I'm only going to ask you to find the scale factor given a new length and an old length, which means the only formula you need is that K is equal to the image divided by the pre-image. When we first took our notes, I let you know that this is the same as new divided by old, but I never want to say new divided by old. We're going to use the vocabulary, image and pre-image. Area. The only thing you're going to be tested on is using a scale factor to apply to an area, meaning the only formula you need is pre-image times k to the power of 2, because area is always 2-dimensional, equals the image. Don't worry if you forget to write this down on your note card. Don't forget to have a poster at the front of the board for you. Volume. First of all, how many dimensions is it? It's 3. Area was 2. So the formula for volume is the pre-image times k to the power of 3. That will give you the new image. For length, it's 1 dimension. So you're only going to do pre-image times k, which will give you the new image. Notice that here we can write k to the power of 1, but that's redundant in math. We don't like to write our 1s. Looking at number 1, there's an example problem, there's a definition, and there's a formula for you. So the scale factor is the ratio of corresponding dimensions of similar figures. To find the scale factor of the length, here's the formula again. It's image divided by pre-image. From now on, I'm going to highlight the image in blue, the pre-image in pink, and the scale factor in orange of every single problem. So looking at the practice problems to find scale factor, a model of a car is built to a scale and measures 2 feet in length. The actual car it represents is 10 feet long. Calculate the scale factor between the model and the actual car. Discuss why scale factors are important in design and modeling. So interestingly enough, this one's a little ambiguous in that you don't really know which one is which, so let's just pick one. We're going to say that the car it represents is the image, and the scale is the pre-image. Because what came first, the model or the car? Let's pretend that we're drawing our blueprints, and that means that the pre-image will be the model. So I'm going to write out image divided by pre-image. My image is blue, so 10 feet divided by 2 feet will be 5. This will be my scale factor. Notice that scale factor is unitless. It means there are no units. You leave it as 5. Why are scale factors important in design and modeling? Because you get to draw things like on your blueprint project. You get to draw blueprints and then you blow them up into real life. And it's a good way to discuss how things are made, what dimensions you expect to be made. Later on, you can start calculating things like cost of making, price of making it. You can say a lot in this discuss why. We're going to do next we're going to do using a scale factor to apply to a length. So it says to find a new length using a scale factor, you multiply the original length by the scale factor once. So image in blue, pre-image in pink, scale factor in orange. Let's try to remember that. A ribbon is originally 5 meters long. That tells you originally, that's a key word for pre-image, which is pink, so I'm going to highlight that in pink. Originally 5 meters long. You decide to cut it into smaller pieces. One piece needs to be scaled down by a factor of 0.4. Scale factor is orange, so I'm going to highlight that in orange. This is my scale factor. Then I'm going to plug it into my formula because it's asking me what will be the length of this smaller piece of ribbon. So it's asking for the image. So we're going to take the pre-image, which is 5, multiply by the scale factor, which is 0.4. It's a length, so I don't need to do any squares or cubes or anything else. I'm going to put this in the calculator. This is going to be 2 meters. We're done. 5 meters times the scale factor of 0.4 equals our 2 meters. Let's look at the Lego set now. A Lego set is 1/100th the size of a real building. This 1/100th is our scale factor. If the building is 1,000 feet long, how long is the Lego set? So 1,000 feet is our pre-image. The Lego set, or it's asking for the image. So we're going to do 1,000 feet. Its length, so we're only going to multiply by the scale factor once, so times 1/100. This will give us the length of the Lego set, which is 10 feet. Pre-image in pink, scale factor in orange, image in blue. Let's move on to some area problems. So it says to find a new area using a scale factor, you're going to take the original and apply the scale factor twice. Remember, you're only ever applying it twice or 3 times to the scale factor. A rectangular park has an area of 50 meters. The City Council has decided to enlarge the park's layout by a scale factor of 2. So our scale factor is 2 to accommodate more visitors. What will be the new area of the park? Show your work. What will be the new area of the park? We're looking for the image again. That means this is our pre-image, 50 meters squared. So we're going to take our 50 meters squared. We're going to multiply by the scale factor twice. Apply the scale factor twice to area problems because area is 2 dimensions. So this is the same as 50 meters squared times 4, which is 200 meters squared. And yes, I want to see your units. I need to see your units on the test. If you do not give me the right units, you will not be getting a 4. One of the math practices is attending to precision. So we must be precise. We cannot let up on you applying the wrong units. Be thoughtful, be mindful, be demure. Let's look at the next one. A blueprint for a house shows an area of 80 feet squared. That's going to be our pre-image. The construction team plans to build the house at a scale factor of 0.75 to fit a smaller lot. What will be the area of the actual house when constructed? So that's what will be the area of the actual house when constructed. So again, we're going to go pre-image times the scale factor twice will give us our new answer. Discuss how scaling down affects the area of objects. First of all, I need to find my calculator. So we're going to do 80 times 0.75 times 0.75. It's going to give us a new area of 45 feet squared. So 80 was our pre-image. Our scale factor was 0.75. And our new one is 45 feet squared. What I want to see out of discuss how scaling down affects the area of objects is just it scales down both dimensions, the length and the width. Let's look at volume now. To find the new volume using a scale factor, you take the original and apply the scale factor 3 times. So nothing's really changed other than instead of twice or once, it's 3 times. A fish tank has a volume of 40 liters. Here's our original. If the tank is scaled up by a factor of 2, so scale factor of 2, to provide a better living environment for the fish, what will be the new volume of the tank? Describe the steps you took in your calculations and why it's important to consider volume when scaling objects. So it wants to know what will be the new volume of the tank, because we want to buy more fishies. So 40 liters times the scale factor 3 times. This will be 40 liters times 8, which is 320 liters. Our new tank will be 320 liters. So pre-image times scale factor equals image. Our last one. A box is used for shipping. A box used for shipping has a volume of 100 centimeters cubed. That's our pre-image. If the box is resized for a smaller shipment by a scale factor of 0.5, what will be the volume of the smaller box? What will be the volume of the smaller box? Our pre-image is 100. Scale factor of 0.5. We're still in volume, so it's to the power of 3. This will give us our new answer. So 100 times 0.5 times 0.5 times 0.5. 12.5. And I'm sorry, I messed up. I should have put centimeters cubed. This will be, again, 12.5 centimeters cubed. Let's round it off with pre-image in pink, scale factor in orange, and our answer, our image, our new volume in blue. The last skill that we need, and I forgot to put it on the study guide. Say you have points on the coordinate plane. Let's do something easy. Let's say we have 3 points. These points are 0, 3, 4, 0, and negative 3, comma 2. So these are going to make a triangle. 0, 3 is somewhere here. 4, 0 is somewhere here. Negative 3, 2 is somewhere here. So this will make a triangle. Let's say I want to scale all of these points. We'll call them A, B, C. So A, B, C. Let's say I want to scale them by a factor of 2. Sorry, I was looking for another color. I'm going to take each of these points. My new point will be at 0 times 2, comma 3 times 2. This will give me my new coordinates for all of them. So A prime will now be at 0 times 2 is 0. 3 times 2 is 6. This will give me my new A prime. 0, 6 is somewhere over here. 4, 0. 4 times 2. So B prime will be at 8, 0, which is somewhere off the grid. This will be B prime. C prime, negative 3 times 2 is negative 6. 2 times 2 is 4. So negative 6, 4, somewhere over here. This will be C prime. Make sure you draw your figures though. You're done. That'll be it. You will do great on the CSA. My students did great last year. I know you guys will do great. Good luck.